Let us take the example of an arithmetic progression whose first term is A and the common difference is D. The standard terms that we are normally using to represent the first term and the common difference. So how will that arithmetic progression look like? The first term is A. The second term is got by adding the common difference to the first term. So A plus D. The third term is got by adding common difference to the second term. So I will get A plus D which is A plus 2D. And here I will get A plus 2D plus D which is an A plus 3D, and goes on till how much ever number of terms I want to write in the arithmetic progression. It can be finite or it can be infinite, as I told you. Now this is the first term, right? This is the second term. This is the third one. And here you have the fourth one. Now this is A plus 0D, correct? A plus 1D, A plus 2D, A plus 3D, etc. This is our fourth term. Okay, now here you can see the first term is correct. 0 I am writing as 1 minus 1. This I am writing as 2 minus 1. Here I am writing as 3 minus 1. Here I am writing it as 4 minus 1, just to represent 0, 1, 2 and 3 in this way, so that I can arrive at a common formula for the nth term. So here you can see that the first term, here the coefficient is 1 lesser than the term number. Here it is a second term, but you have here 1D. Here it is a third term, you have here 2D. Here it is a fourth term, you have got 4 minus 1, 3D. So can you tell me how will the fifth term will be? The fifth term will be A plus 5 minus 1 into D, which is A plus 4D. Correct? So what will be the 100th term? The 100th term will be A plus the term number minus 1 into D, which is A plus 99D. So what will be the 1000th term be? A plus 999D. Suppose you have got n terms in the AP. We don't know the value of n right now, but we have got n terms in the AP. So how will the nth term look like? The nth term will be A plus term number minus 1 into D. Our nth term of the AP is A plus n minus 1 into D, where n is a number of terms and it is represented as A n. Okay, so the first term I can represent it as A1, the second term I can represent it as A2, this is A3, this is A4, A5 up to AN. Okay. Suppose we have an AP whose terms are A1, A2, A3, A4, A5 up to AN. The first term is A and the common difference is D, which means that A1 is equal to A, A2 is A plus D, A3 is A plus 2D, A4 is A plus 3D, AN is A plus n minus 1 into D. So before AN I have got n minus 1th term. So what is the formula for the n minus 1th term? An is given by this, correct? Wherever n is there in the formula, you have to substitute n minus 1. So you will get A plus n minus 1 minus 1 into D, or A plus n minus 2 into D. Right? Use this formula, or use this is our standard formula. Use that formula to write the 55th term. So A55 is equal to A plus 55 minus 1 into D, which is A plus 54D. So I hope you are clear with the formula approaching from here and from here also. Both ways, using the formula to write the term and writing the term to reach the formula. So only thing over here to make clear is An is equal to A plus n minus 1 into D. where A is the first term, An is the nth term, and D is the common difference. Okay, now let us do a few sums on this particular concept. Find the 100th term of the AP 2, 7, 12, 17. Okay, now whenever you are having a sum, it always makes it easier when you write down the information that you are getting from the sum and the information or any of the formula that you already know regarding the sum. So here this is an AP, so it has to have a first term and it has to have a common difference. So here you can see the first term is a 2. The common difference is 7 minus 2, which is a 5. Okay. Now we need to find the 100th term. In order to find the 100th term, we know the formula for the nth term. So an or the nth term is a plus n minus 1 into d. So I need to find a 100. So a plus 100 minus 1 into d, or a plus 99 d. Substituting the value, you will get, okay, so this is equal to you will get 497 as the 100th term of this particular AP. A very straightforward sum, direct application of the formulas so that you get a basic idea on how to apply this formula. Okay, now let us move on to other sums. Which term of the AP 4, 9, 14, 19 is 124? So an AP is given to us over here and we need to find, see, and it's also from this question we understand that 124 is a term in this AP. We need to find the position of 124. So which number term or which term is 124 in this particular AP? A slightly more complicated sum than the straightforward one that we did previously. So let us see how we can start this. I told you to write all relevant information that you know. So you know that this is definitely an AP with a common difference of 5. The first term is a 4. Now let us write the nth term formula or the formula for the nth term of an AP, which is an is equal to a plus n minus 1 into d, and because we do not know which term is 124, let us assume it to be the nth term. Okay, so an, we don't know the value of n. It can be 20th term, it can be 30th term, it can be the 100th term, or it can be just the 10th term, anything. So randomly we have to find the value. Randomly I am assuming 124 to be the nth term till we find the value of n. Okay, so what is the formula? A plus n minus 1d is 124. I know the value of a. I do not know the value of n. I know the value of d. Correct. So I will get n minus 1 into 5 is equal to 124 minus 4, 120. Okay. So what is n minus 1 over here? N minus 1 is equal to 120 by 5, which is 24. Correct? Fine. So the value of n is 24 plus 1, which is a 25. So I can say that 124 is a 25th term of this particular AP. Clear? We are assuming 124 to be the nth term. Substitute the relevant values and find the value for n. That is all. How many terms are there in the sequence 3, 6, 9, 12 up to 101? Now, please remember, it is not mentioned whether this is an arithmetic progression or not. Now, our task is to first show that it's an arithmetic progression. We show that by showing the common difference is the same between the consecutive terms. So, here the common difference is a 3. Here it's a 3. Here it's a 3. So, since the common difference is shown to be constant over here, you can say that it's an arithmetic progression. Now, when you are having this question in the examination, please write the common difference is the same between the consecutive terms, which is equal to 3. Here is this sequence is an arithmetic progression. Okay. Now, we have to find the number of terms. I told you, write down the information you have. A is equal to 3 and D is equal to 3. Correct. Now, we need to find the number of terms. So, number of terms let there be n number of terms. If there are n number of terms in this whole arithmetic progression, the last term has to be the nth term. Suppose there are p number of terms in the arithmetic progression, the last term has to be AP. So here, since there are n number of terms, the last term is AN. AN is equal to 111. We know the formula for the nth term, correct? AN. Okay, what is A equal to? It is 3 plus n minus 1 into 3 is equal to 111. N minus 1 into 3 is equal to 108. N minus 1 is 108 by 3. So you will get 36. Or n is equal to 36 plus 1, 37. So there are 37 terms in this arithmetic expression where the last term or the 37th term is 111. If the 8th term of an AP is 31 and the 15th term is 16 more than the 11th term, find the AP or find the arithmetic progression. Now, this is a very common question that I have seen in question papers. If you check the previous year's question papers, you can find that this type of question is very commonly asked. Now, let us figure out how we can do this. Write down the information you get from the question and write down the information what you already know. Okay. So, 8th term of an AP is 31. So, we know that the given question is based on arithmetic progression. It has the first term and it has a common difference. Both the values we have no idea. Now, since the 8th term, 15th term, all that are given, we know that the formula we need to use is a formula for the nth term. So, you will write AN is equal to A plus N minus 1 into D. This is what we know on our own. Now, what do we get from the question? 8th term of an AP is 31. 15th term is 16 more than the 11th term. Fine. This is all that we know. Now, we need to find the AP, exact value of the terms of the AP. 8th term is 31. So, can I write the formula for the 8th term? The 8th term will be A8 is A plus 8 minus 1 into D, which is 7D. Correct. What is A15? A plus 15 minus 1 into D, which is 14D. What is A11? It has to be A plus 10D. Okay, we know. Let us substitute these values in this formula. Sorry, in this information that we have written down. A8 is equal to 31. A plus 7D is 31. Okay. A11 and A15 we know. So, which is A plus 14D is given to be 16 plus A11. So, suddenly in the second equation, we find that we can cancel A on both the sides. Thankfully, we will be left only with D. So, cancelling A over here, what do you get? You get 14D is equal to 16 plus 10D. When I am solving it, I will get 4D is equal to 16 or D is equal to 4. You got the value of D. Now that you got the value of D, look at the first equation. If you substitute D over here, I can find the value of A. So let us see what is the value of A. After substituting 4 in this equation, I am getting A plus 28 is 31 or the value of A is equal to 3. Now to write down an AP, we need only the first term and the common difference. So let us write the first term is 3. The second term is 3 plus 4, A plus D. The third term, which is 7 actually. The third term is 7 plus 4, which is an 11. Then it is 11 plus 4, which is a 15, etc. So, this is our required AP. Which term of the sequence 20, 19, 1 by 4, 18 and a half, 17, 3/4 is the first negative term? Oh, I keep forgetting this. So, it is mentioned that it's a sequence. So, we need to decide if it's an arithmetic progression or not. That is our first step. So, let us take the difference between the consecutive terms. So, 19 1/4 minus 20. That is the difference between the second term and the first term. So you will get it as minus 3 by 4. Now 18 1/4 minus 19 1/4 also you should give you minus 3 by 4, and 17 3/4 minus 18 and a half also will give you minus 3 by 4. So as you can see, this is a decreasing AP, so the common difference is rightly negative. Now we need to find which is the first negative term. So as I told you, let us first write down the information that we are having. Sorry, the first term is a 20. The common difference is a minus 3 by 4. Now let us take that formula for the nth term. It is a plus n minus 1 into d. Correct. Now they are asking you which term of the sequence is the first negative term. So we are going to take that. Let the nth term be the first negative term. So let an be the first negative term. So how do you identify a negative term? Obviously the negative term will have a negative sign, meaning it is lesser than 0. Okay. So an is lesser than 0, or a plus n minus 1 into d is lesser than 0. So applying this condition, we need to find the value for n. Okay. So what is the first term? 20 plus n minus 1 into minus 3 by 4 is lesser than a 0. You have an inequality, see, lesser than. So let us see how we can find the value of n by solving this inequality. So the first step is to open the bracket. So when you open the bracket, you will get, here I will do it, 20 plus 20 minus 3 by 4n plus 3 by 4 is lesser than a 0. Okay, so I have opened the bracket over here. 20 minus 3 by 4n plus 3 by 4. So 20 plus 3 by 4, I can take the LCM and I will get 83 by 4 minus 3 by 4n is lesser than a 0. Okay, now I have to solve for the value of n. So I am going to take this 3 by 4n to the other side. So I will get 83 by 4 is lesser than 3 by 4n. Okay, or in other words I can say 3 by 4n is greater than 83 by 4. Fine. So I can say 3 by 4n is greater than 83 by 4. Fine. Or n is greater than 83 by 4 into 4 by 3 or 83 by 3, which is approximately 27 and something. There is a fraction that happens. I guess it will be 2 by 3. So 27 and a fraction over here, 2 by 3. So my value of n has to be greater than 27 and 2 by 3. So what does it mean? N is the number of terms. I can have only natural number values for n. So it has to be either 27 or it has to be either 28. I cannot have 27 and 2 by 3 or 27 and some 1 by 3, a value like that. So n greater than 27 and 2 by 3 means the next immediate value is 28. So the value of n has to be 28 for the first term in this particular progression to be negative. Clear? It is very simple. You just have to write the formula for the nth term and equate it to be lesser than 0, because we need to find the first negative term. So after equating it to 0, open the bracket and solve for it. In this particular question, there can be a slight variation. Can 0 be a part of this particular arithmetic progression? So now let us see how we can tackle that particular sum. I am retaining all the information that we already wrote for the previous question because it is the same value over here. So I have a is equal to d, a is equal to 20, my bad, d is equal to minus 3 by 4 and the nth term, and we need to find if 0 can be a part of this particular progression. So starting the sum, we are going to take that 0 is a part of this progression. So let 0 be a term in this AP. So if 0 is a term in this particular AP, it has to have a particular term number. Either it can be the 5th term, or it can be the 29th term, or the 100th term, whichever. We need to find what is the term number for 0. Okay. So for that we will take, let nth term be equal to 0. Okay. And we are going to write the formula a plus n minus 1 d is equal to 0. Now we are going to substitute for a and we are going to substitute for d from these values and find the value of n. So here I have substituted the values of a as well as d over here, and I have solved for n as 83 by 3. So when I am actually equating the nth term to 0 and trying to find the value of n, I am getting 83 by 3. 83 by 3 is a fraction. Okay, it's an improper fraction, but it's nevertheless a fraction. It is not properly divisible. So the value of n, or the number of terms, has to be a natural number. Okay, it has to be either the first term or the second term or the third term. It cannot have a fractional value, because when I am equating the nth term to 0, I am getting a fractional value. 0 cannot be a part of this arithmetic progression. Fine. So I hope you are clear with how to approach the previous sum as well as this particular sum. Write the formula for the nth term, and if it is a if we have to find the first negative number, you have to write it less than 0, which is the first negative term. A plus n minus 1d is less than 0. If you have to find if 0 is a part of this progression, equate it to 0 and find the value of n and see whether it is a natural number or not. Okay.